Hi everyone, and welcome to this fourth video on trigonometric ratios. In this video, we're going to see why trigonometric ratios are useful in the first place, how they help us in understanding triangles and the applications in engineering, architecture, construction, all of that. So of course, last time we talked about the three main trigonometric ratios, and hopefully you have these already written down, but they are sine, cosine, and tangent. And one thing you may have noticed last time when you were examining different trigonometric ratios is that the trigonometric ratios are always going to be the same for a given angle in a right triangle. Really important that this only applies to right triangles. But that means if you have a right triangle with, for example, a 30-degree angle, the sine will always be the same in any right triangle. In this case, the sine is 0.5 in any right triangle. What does that actually mean? That means for any right triangle, again, really important, these are only right triangles, with a 30-degree angle, the sine ratio, which of course is opposite divided by hypotenuse, will equal 0.5. For any right triangle with an angle of 30 degrees, the opposite divided by the hypotenuse will be 0.5. And in fact, calculators can tell us the sine, cosine, and tangent of any angle. So the first thing you're going to need to do is get out your graphing calculator and find the sine, cosine, and tangent buttons and use them to find the sine of 45 degrees, or the cosine of 45 degrees and the sine of 60 degrees. And just fill in these two gray squares in your table using the information your calculator gave you. If you can't find those buttons, let me know or ask a friend. All right, I'll pause, let you get this all written down, and then we'll go into how can we actually use these ratios to find missing sides. Okay, so we can use trigonometric ratios to find the sides of what kind of triangles? Right triangles, even when we only know one side. So in the past, in 6.2, we talked about using the Pythagorean theorem to find missing sides. That works if we already know two of the sides. In this case, we'll see an example of how even if we only know one side, we can still find the missing sides. Okay, so the first step is to label the sides of the right triangle. And we will do that now. The angle we're looking at in question is down here, which means the opposite side is over here. It's opposite that angle. Opposite the 35-degree angle. 8 is the longest side. It's opposite the right angle. So this will be the hypotenuse. And then this remaining side is the adjacent side. It's next to the angle, but it's not the longest. So it's the adjacent. So we've labeled our sides, opposite, hypotenuse, adjacent, and circled the angle that we need. Now we need to choose which trigonometric ratio we will use. If we have the opposite and the hypotenuse, we're going to use sine because that is the one that has the opposite and hypotenuse in it. If we have the adjacent and hypotenuse, we will use cosine. And if we have opposite and adjacent, we will use tangent. In this case, we have the hypotenuse and the opposite side. We don't care about the adjacent side. We care about x and 8, opposite and hypotenuse. So we're going to use sine. So let's go ahead and see how we can do that. Step 3, we're going to write an equation using our chosen trigonometric ratio. We know that sine in general, and this is in your notes from last time, so it's really important you have those notes written down. Sine is equal to opposite over hypotenuse. I'm just going to abbreviate it op divided by HYP. Now we're going to put in the specific information from this problem. So in this case, it's sine not of any angle, but of 35 degrees. Sine of 35 degrees equals the opposite, in this case is x, and the hypotenuse in this case is 8. So now we have an equation with the specific information from our problem. Finally, all we need to do is solve this equation using the trig function on our calculator. So we can go into our calculator and put in sine of 35 degrees, which is what I'm going to do right now, because I don't know what it is. Sine of 30 degrees looks like it is 0.5738. We'll round it there. use as many decimal places as you can, because otherwise your answers are going to be a little bit inaccurate. So 0.5738, I just got this from a calculator, equals x divided by 8. Well, we are trying to figure out what x is, so we got to get x alone. We got to get rid of this divided by 8. How do we cancel out dividing by 8? Times 8. So I'm going to use a dot to represent multiplication. Times 8 times 8. Again, just do this on your calculator. 0.5738 times 8 equals 4.589. 4.589. We'll cancel out these 8s, and we're just left with x equals 4.589. There's our answer. We can look at the triangle and see, does this answer make sense? And it looks like it does, right? This side is less than 8, so it makes sense that it's about 4.5, 4.589. If we'd gotten an answer like 1, that would have probably been too small. If we had gotten an answer like 20, we would have known we made a mistake. So in this case, we got 4.589, and there's our answer. Let's do one more example. So I will clear this, go on to the back of your notes, and we'll go through the same steps. So again, we have a triangle. Step 1 is we're going to label the sides. First, let's find the hypotenuse. Hypotenuse, longest side across from the right angle. So it is down here. Then we know we're considering this angle here. So what is opposite this angle? Well, it's this side over here. So 4 is the opposite side. And finally, the last side next to the angle that's not the hypotenuse is the adjacent side. So we have done step 1, which was label sides. Now, step 2 is to choose trig ratio, right? Which trigonometric ratio are we going to use? Well, in this case, the information we have is that the opposite equals 4 and the adjacent equals x, and we don't care about the hypotenuse. So we want to use a trig ratio that includes the opposite and the adjacent. You can look back at your notes from 6.3, and you will see that the ratio we want is tangent. Tangent is equal to opposite divided by adjacent. Okay, so now we need to plug in values from the triangle, substitute in values from triangle to equation. Write the equation. So tangent is not just of any angle, but it's the tangent of 41 degrees, because that's the angle we're considering, equals opposite divided by x. Now this one's a little bit different because the x is on the bottom. So again, we can do tangent of 41 degrees in our calculator, and I will do that real quick. Tangent 41 degrees, and it is equal to 0.8693 about, equals 4 divided by x. Now the problem is we can't cancel out this 4 because right now the x is doing the action. We are dividing by x. So to solve this equation, we're going to need to do 2 steps this time. First, we're going to do times x on both sides to cancel out that divided by x. And this is going to go up over here. So 0.8693 times x is just 0.8693x, right? And that equals 4 because we canceled out the divided by x, so now it's just 4. Now we need to get the x by itself, so we're going to want to divide by this decimal that's with the x, 0.8693 divide by 0.8693, and we will do this on the calculator. 4 divided by 0.8693, and we get x equals 4.6 about. So that tells us that this side up here is 4.6. And I think that looks like about the right answer, because it's about as long as this side, a little bit longer. So it's 4.6 centimeters. It doesn't actually say the unit. long. I hope that's helpful. If you have questions, of course, you can rewatch the video. You can just Google using trig ratios to find other videos. And I would go ahead and get started on the practice now. Good luck and bye-bye.